Yo, yo, LG Brainiacs, welcome to the Johnson Kendra video hour.
But it's not an hour.
Oh, I'm really sad. You didn't ever do an hour video. Do you want to do this one an hour?
Maybe we should just like hang out after and
We'll just
record
say,
ourselves.
yeah, we can make it an hour. Come on. We'll see. We'll see how it goes. Okay.
So we're taking it a little further with a normal
another
distribution.
jump up. All right, so the scores of an Algebra 2 final are approximately normally distributed with a mean of 150 and a standard deviation of 15. All right, so we got those two pieces of info. Very important.
Let's draw the curve.
Okay.
So
Hey,
we should
you
be
already
good
got
at this.
those in.
Yeah, I was trying to save some time. So 150 is the mean, so I'm going to put that smack dab in the middle of the curve.
Very nice, very nice.
All right, so standard deviation is
15.
15, so we're always going to be working in intervals of 15.
Oh, good, that's easy to add.
Okay.
So,
So,
should we label it?
yeah, let's
Left first.
Okay,
135,
so she's subtracting 15.
120,
Uh-huh,
105.
makes sense. All right, to the right of the mean.
165, 180, 195.
All right, you might also want to recall our facts. One standard deviation contains how much of the data?
68.
Yes, 68%. Two standard deviations of the mean contain
95,
95% of the data, and three standard deviations contain
99.7.
and then 0.15 on each side outside of three
All
standard deviations. Okay, so let's use that in both. What percentage of students who took this exam scored above a 180?
Okay, so we got to put those numbers in the blanks or
Yeah,
the
we can do that.
spaces.
Yep.
Make our math easier.
So one standard deviation is here, and there's 68% of the data, so maybe I should label each slice we got going here.
34, 34.
Okay, I'm getting that, she's getting that by cutting 68 in half.
Okay.
All right, two standard deviations was 95%, so that's adding 27% more.
Cut 27 and a half, that's 13.5 on each.
And these are things you don't necessarily need to memorize. Probably you're going to get really familiar with them,
Yeah.
because you can always calculate them, but
And the
Okay.
last one is
Is-
4.7, so that's 2.35.
I went too far.
You're going too far now.
So within three standard deviations, you said was 99.7, so there's 2.35 on each side because there's really 4.7 left.
All right.
Don't forget, there is more data. There's 0.3%, so half of that is here. That's outside of three standard deviations, and 0.15% is here.
Okay.
All right, so this question asks, what percentage of students who took the exam scored above a 180?
So those two spaces we got to add together.
So 2.35% plus, don't forget these guys,
So 2.5 is what I get.
percent of the students. Very good.
Well, those are the smarty pants.
Yep.
All right. If 250 students took the final exam, approximately how many scored above 135?
So notice this, sometimes they're going to ask for percent answers, sometimes they're going to ask for numerical answers. That's really important. So above 135, so here's 135, maybe I should get a new color we haven't used yet. Here's 135 people that scored above. We could add those little slices, but I want to show you something. What does the mean do to the data? Cut it
Cuts it in
in.
half.
So we know already 50% of the data has to be to the right of that. So 50% plus, what didn't I count yet?
34%.
Yeah, is 84. Now that's a percentage.
But we got to figure out of 250, so 84% of 250.
How do you do that?
Of means to multiply.
Oh yeah, 0.84 times 250,
And I get 210.
210 students.
Good thing you labeled it. Nice job.
Trying to get a good score on the SAT.
There you go.
All right, if 3.16% of the students received a B on the final, how can you describe their scores? I like this question.
13.6.
Yeah, did I say
You said
30?
3.16.
Oh my. Okay.
Must be late in the day.
No, 13.6.
That's all good, unless I was hearing wrong. Maybe
Nope,
that was
I
my
don't
fault.
know. We'll have to rewind later and check it out.
Okay.
All right, so the way that we're going to approach this, we need to find a spot on our curve where we have a chunk of kids that are pretty close to 13.6.
Okay.
So do you see any areas that contain about 13.6% of our data?
I see a 13.5.
Close enough.
Okay.
And isn't there another one?
Uh-huh.
Now, one of those is right, one of those is wrong, because these kids got a B on the test.
So one of them, because this normally distributes all the grades, there's A's, B's, C's, and D's, and E's.
Yeah.
So I'm thinking the one to the right is the B's because that's a better score.
Yeah, it's a higher grade, it's close to the A's. So she's talking about this chunk of data, but this question asks us to describe the score. So the range of the scores would be about,
5
yeah,
to 180.
cool,
All right.
sounds good.
Okay, a set of data has a normal distribution with a mean of 29 and a standard deviation of 4.
I will say some kids will easily be able to answer this without drawing the curves, especially maybe number 2. Let's go backwards.
Okay. Greater than 29. Well, I see a 29 up in the direction there.
And
The
that's
average, the mean, the middle.
Yeah. So if you need the curve, go ahead and draw the curve, but remember 29 is in the middle, so how many kids are here?
50%. Half of
Yeah.
them. Nice.
All right. And then question 1, we'll go back to. Scored from 25 to 33. So what do you notice about those numbers?
Well, they're smaller than 29. Or
Yeah.
no, they're between
How much less?
4 in both directions.
Oh, isn't that a standard deviation?
Huh.
So 25 would be the label here, and 33 would be the label here because the standard deviation was 4 units. So how much data is contained
Well, the
within
one
one standard
standard.
deviation?
And that's 68%.
Yes, it is.
So those are pretty easy if you
Yeah.
just know those percentages.
Feel free to label a curve if that helps you. All right, last thing, very similar to our first question. Suppose the time required for an auto shop to do a tune-up is normally distributed with a mean of 102 minutes. That's a long time.
Yeah, well,
And
that's why they make the big bucks.
I guess, standard
Okay.
deviation of 18 minutes. What's the probability that a tune-up will take more than 2 hours? By the way, do you notice that's in hours and not minutes?
Minutes, so 120.
Yeah. All right, my steps. As always, draw a normal curve. Make sure you get your labels on there. Mark the intervals, and then we'll use those predetermined percentages to decide. I'm going to get my curve on here. Get my curve on. All right, will you help me with the labels?
I will. So 102 is the mean.
Okay.
Then we have to go 18 minutes in each direction. All right, so to the right, 120,
Uh-huh.
138, 156.
156.
To the left, 184. I mean, 84.
Just 84,
Yep.
yeah.
66 and 48.
That sounds good. All right, so this question wants us to know what's the probability that a tune-up will take more than 2 hours, which you helped me figure out is 120 minutes.
Okay. Probability.
Okay. Also, this year they're not getting a lot of probability stuff. That's going to come in geometry class. But the math language way to write probabilities is with capital P, and I'm going to put greater than 120 minutes. So this says, in math language, the probability that something takes more than 120 minutes.
So we just got to get those normal percentages that are in those spaces and add them up.
All right, so this would be one standard deviation. So that's 34.
Yeah.
Do you remember these? 13 and a half, right?
Yep. And then 2.35
Don't forget about this.
and 1.15.
I actually think there is a very efficient strategy to do this one. Maybe more efficient than adding all the decimals.
Well, we know the left side is 50%, so that's gone.
Yeah.
And the 34% is gone. So maybe if we add those two and subtract from 100.
Yeah. Or even I was thinking, here's 50%. Can't we just do 50% of the data has to be that way? 50 minus the 34 I don't want.
Yeah.
So lots of different ways. And when we do that, we get 16%. So 16% chance we gotta wait more than 2 hours for our car, which is a long.
Yeah, that's
sleeping
probably
time.
me, because I always end up having a lot of car problems that take forever. Okay, it's tough to be an adult.
It is.
Alright, what's probability that a tune-up will take under 66 minutes? Well, nice, they put it in minutes this time.
All right, so 66 on our normal curve is over here.
Now, I just think adding those two columns would
Yeah.
be the easiest.
So let's make sure this is our 34 and our 13. So this is
0.35.
percent, and then yeah, 0.15 outside of 3 standard deviations. So you said Adam,
2.5.
2.5% chance that we're waiting less than an hour and 6 minutes. I think we need a new auto guide.
Yep, I do too.
Yeah,
Alright, very good.
that's it.
That's it.
Ta-ta.
Ta-ta for now. And for a while.
Wait, should we hang out for an hour?
Yeah, we could sing. We want to sing. Go, go, you Lakers, go. Show them all your might. Rah, 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 go. Go,